It started in 1993.
Ready, go!
With NV1, we wanted to build computers that can do things that normal computers couldn't. And NV1 made it possible to have a game console in your PC. Our programming architecture was called UDA, missing the letter C until a little while later, but UDA, Unified Device Architecture. And the first developer for UDA and the first application that ever worked on UDA was Sega's Virtual Fighter. 6 years later, we invented, in 1999, the programmable GPU. And it started 20 plus years of incredible advance.
Hola, gente.
In this incredible processor called the GPU. It made modern computer graphics possible. And now, 30 years later, Sega's Virtual Fighter is completely cinematic. This is the new Virtual Fighter project that's coming. I just can't wait. Absolutely incredible. 6 years after that, 6 years after 1999, we invented CUDA so that we could explain or express the programmability of our GPUs to a rich set of algorithms that could benefit from it. CUDA initially was difficult to explain, and it took years, in fact. It took approximately 6 years. Somehow, 6 years later or so, 2012, Alex Karshevsky, Ilya Sutskever, and Jeff Hinton discovered CUDA, used it to process AlexNet, and the rest of it is history. AI has been advancing at an incredible pace since. Started with perception AI. We now can understand images and words and sounds. To generative AI, we can generate images and text and sounds. And now, Agentic AI. AIs that can perceive, reason, plan, and act. And then the next phase, some of which we'll talk about tonight, physical AI, 2012. Now, magically,
Hola, chat. ¿Qué pasó, Francisco? ¿Cómo estás, amigo? Buenas noches.
Something happened that was pretty incredible. Google's Transformer
Estoy poniendo
was
apenas
released as
los
first.
links. Ya me dejaron, hermano. Por eso luego prendí stream. No me habían. No, según no tenía y ya puedo.
Transformers, as you know, completely changed the landscape for artificial intelligence. In fact, it completely changed the landscape for computing altogether. We recognized properly that AI was not just a new application with a new business opportunity, but AI, more importantly, machine learning enabled by transformers, was going to fundamentally change how computing works. And today, computing is revolutionized in every single layer, from hand coding, instructions that run on CPUs to create software tools that humans use. We now have machine learning that creates and optimizes neural networks that processes on GPUs.
¿Cómo estamos, Francisco?
Artificial intelligence.
Ok, gente, bienvenidos al stream del CES 2025. Voy a poner los subtítulos, no se puede, pero bueno, voy a tratar de decirles cuando pase algo. Hoy anuncian la RTX 5090, gente, la 5080, y nos dan el roadmap, yo creo, de lo que va a pasar con 5070, 5060 y las cosas de inteligencia artificial y todo lo de Nvidia. Pero a ver. Al principio de la conferencia salió como el dueño, por así decirlo, de la CES, diciendo que pues Nvidia iba a ser la primera presentación de todo el evento y todo eso, y de que si el brother hubiera escuchado hace unos años invertir en Nvidia, probablemente ahorita ya no tendría que estar haciendo esto. Se mamó, su chiste estuvo bueno, la verdad. Hola.
AI driven, AI native, at the core of it, this fundamental concept is there. Machine learning has changed how every application is going to be built, how computing will be done, and the possibilities beyond. Well, GPUs, GeForce, in a lot of ways,
¿Creen que entren
all of
luego con la
this with AI
5090?
is
Yo
the
haría
house
eso.
that GeForce built. GeForce
Debería,
enabled AI
debería.
to reach the masses. And now, AI is coming home to GeForce. There are so many things that you can't do without AI. Let me show you.
La
Some of it
5090. Yo creo que
now.
va a costar como $2,500. El siguiente renderizado es en tiempo real usando Blackwell. Ok. Ay, ese mamá. Ay, ese güey. Más como 2 segundos atrasada. No mames, que imagínense los juegos del futuro, viejo. No me digas. Mi hijo va a vivir la mejor generación de juegos, güey. No, se ve muy loco eso. Ok. Uy, el ray tracing. Uy. Ok. ¿Se viene el cambio? Ok, no entendí mucho ese cambio, gente. No entendí mucho ese cambio. Ay, ya sé que me color, pero no entiendo por qué. A ver, ahí se viene. Ok. DLSS Transformer, eso es nuevo.
That was real-time
Bravo.
computer graphics.
Bravo, estuvo bueno. Eso fue todo en tiempo real, chava. O sea, es como si estuvieran jugando. No fue ni siquiera un render, fue en tiempo
No
real.
computer graphics
Estuvo bueno,
researcher,
estuvo bueno.
no computer scientist would have told you that it is possible for us to ray trace every single pixel at this point. Ray tracing is a simulation of light. The amount of geometry that you saw was absolutely insane. It would have been impossible without artificial intelligence. There are two fundamental things that we did. We used, of course, programmable shading and ray traced acceleration to produce incredibly beautiful pixels. But then we have artificial intelligence be conditioned, be controlled by that pixel to generate a whole bunch of other pixels. Not only is it able to generate other pixels spatially, because it's aware of what the colors should be, it has been trained on a supercomputer back in Nvidia, and so the neural network that's running on the GPU can infer and predict the pixels that we did not render.
Ok.
Not only can we do that, it's called DLSS. The latest generation of DLSS also generates beyond frames. It can predict the future, generating 3 additional frames for every frame that we calculate. What you saw, if we just said 4 frames of what you saw, because we're going to render 1 frame and generate 3. If I said 4 frames at full HD, 4K, that's 33 million pixels or so. Out of that 33 million pixels, we computed only 2. It is an absolute miracle that we can computationally using programmable shaders and our ray tracing engine, to compute 2 million pixels and have AI predict all of the other 33. And as a result, we're able
Wow,
to
la inteligencia
render at
artificial
incredibly high performance because AI does a lot less computation. It takes, of course, an enormous
renderizó
amount of
31
training
millones de
to produce
píxeles,
that,
gente,
but
en
once
tiempo
you
real.
train it, the generation is extremely efficient. So this is one of the incredible capabilities of artificial intelligence, and that's why there's so many amazing things that are happening. We used GeForce to enable artificial intelligence, and now artificial intelligence is revolutionizing GeForce. Everyone, today we're announcing
Se
our
viene-
next generation,
Se viene la serie 5000.
RTX Blackwell family. Let's take a look.
Ahí se viene chat, se viene la 5090, Dios. 32 GB de VRAM, vato, los rumores eran ciertos. Ok. Interesante el conector, cómo está puesto, ok. Memoria G7. Ok. 4000. Ni siquiera sé qué era eso de inteligencia artificial. No sé cómo se miden los núcleos de inteligencia artificial.
Here it is. Our brand new GeForce RTX 50 series Blackwell architecture. The GPU is just a beast. 92 billion transistors, 4,000 TOPS, 4 petaflops of AI, 3 times higher than the last generation Ada. And we need all of it to generate those pixels that I showed you. 380 ray tracing teraflops so that we could, for the pixels that we have to compute the most beautiful image you possibly can. And of course, 125 shader teraflops. There's actually
¿Esa la tendrás, Talent? Claro que sí, Paola Mariana. Claro que sí. ¡La necesito!
Dual shaders. One is for floating point, one is for integer. G7 memory from Micron, 1.8 terabytes per second, twice the performance of our last generation. And we now have the ability to intermix AI workloads with computer graphics workloads. And one of the amazing things about this generation is the programmable shader is also able to now process neural networks. So the shader is able to carry these neural networks, and as a result, we invented neural texture compression and neural material shading. As a result of that, you get these amazingly beautiful images that are only possible because we use AIs to learn the texture, learn the compression algorithm, and as a result, get extraordinary results. Okay, so this is the brand new RTX Blackwell 5090.
Bravo.
Now,
Bravo, chava.
even the mechanical design is a miracle. Look at this, it's got 2 fans. This whole graphics card is just one giant fan. You know, so the question is, where's the graphics card? Is it literally this big? The voltage regulator design is state-of-the-art, incredible design. The engineering team did a great job.
Güey, el chip sí es muy chiquito comparado a los demás chips que habían sacado antes. Por eso dijo que prácticamente era solo un ventilador.
Okay,
Está
so
buena,
those are
gente?
the speeds and feeds, so how does it compare? Well, this is RTX 4090.
4090 versus la 5090.
I know
¡Dios!
many of you have one.
La van a sacar como en $2,000 de seguro.
I know
O
it.
la va a sacar en el mismo
Look,
precio.
it's $1,599.
No te lo creo.
It is one of the best investments you could possibly
La
make.
4090 en $1,600. A ver. A México llegó como en $2,000, pero
To
bueno.
your $10,000 PC entertainment command center. Isn't that right? Don't tell me that's not true. Don't be ashamed. It's liquid cooled. Fancy lights all over it. You lock it when you leave.
Bueno,
It's the modern home theater. It makes perfect sense.
cierto.
And now for $1,500
Cierto.
and $1,599, you get to upgrade that and turbocharge the living daylights out of it. Well, now with the Blackwell family, RTX 5070
No mames,
4090
qué
performance
pedo, güey.
at
¡Uy,
549.
esa mamada! Pero esa es la 5070, chava. No, ¿qué
Impossible
dices?
without artificial intelligence. Impossible without the 4 teraops of AI.
Güey, es el
tensor
precio de
cores.
una 4060 de hoy en
Impossible
día.
without
¿De
the
qué
G7
hablas?
memories. Okay, so 5070, 4090 performance, $549, and here's the whole family. Starting from 5070 all the way up to 5090.
$2,000 la
5090,
5090, lo
twice the performance of a
sabía,
4090.
hermano.
Starting,
Dios.
of course, we're producing at very large scale availability starting January. Well, it is incredible, but we managed to put these in gigantic
No puedo
performance
creerlo.
GPUs
No puedo
into
creerlo.
a laptop. This is a 5070 laptop for $1299.
Una
This
laptop con
5070 laptop
5070
has a
por
4090
$1,300 es muy
I think there's
barato,
one here
muy
somewhere.
barato. Lástima que no estamos en México, hermano.
Let me show
En
you
México
this.
eso va a llegar como en 2,500
This is a-
euros.
Look at this thing. Here, here. There's only so many pockets. Ladies and gentlemen, Janine Paul.
La Janine.
So can you imagine? You get this incredible graphics card here, Blackwell. We're going to shrink it and put it in there. Does that make any sense?
No.
Well, you can't do that without artificial intelligence. And the reason for that is because we're generating most of the pixels using our tensor cores. So we ray
Son
trace only the
laptops.
pixels we
Se
need.
comprime para
And
que se
we
haga una
generate
laptop.
using artificial intelligence all of the other pixels we have. As a result, the energy efficiency is just off the charts. The future of computer graphics is neural rendering, the fusion of artificial intelligence and computer graphics. And what's really amazing is, oh, here we go. Thank you. This is a surprisingly kinetic keynote. And what's really amazing is the family of GPUs we're going to put in here. And so the 5090 will fit
Es
into
muy
a laptop,
barato.
a
Una
thin
laptop
That
con
last laptop was
5090 por
14.9
$2,900.
5080, 5070
Digo,
Ti,
no
and
dice obviamente
5070.
qué procesador ni nada, pero...
So, ladies and gentlemen, the RTX.
O sea, mi
Blackwell
compadre Nvidia
fan.
le quiere competir a Apple, hermano.
Well, GeForce brought AI to the world, democratized AI. Now AI has come back and revolutionized GeForce. Let's talk about artificial intelligence. Let's go to somewhere else at Nvidia.
Hablemos acerca de inteligencia artificial. Vamos a cualquier otro lugar de
This
Nvidia.
is
ok.
literally our office. This is literally Nvidia's headquarters. Okay, so let's talk about AI. The industry is chasing and racing to scale artificial intelligence. And the scaling law is a powerful model. It's an empirical law that has been observed and demonstrated by researchers and industry over several generations. And the scaling law says that the more data you have, the training data that you have, the larger model that you have, and the more compute that you apply to it, therefore, the more effective or the more capable.
Claro, una inteligencia artificial entre más entrenamiento tuvo, mejor va a estar preparada.
What's really amazing is that now we're moving towards, of course, and the internet is producing about twice the amount of data every single year as it did last year.
Hola Daniel Hernández,
In
¿cómo
the next
estás?
couple of years,
Buenas
we'll
noches.
humanity will produce more data than all of humanity has ever produced since the beginning. And so we're still producing a gigantic amount of data, and it's becoming multimodal. Video and images and sound, all of that data could be used to train the fundamental knowledge, the foundational knowledge of an AI. But there are, in fact, two other scaling laws that has now emerged. And it's somewhat intuitive. The second scaling law is post-training scaling law. Post-training scaling law uses techniques like reinforcement learning, human feedback. Basically, the AI produces and generates answers based on a human query. The human then, of course, gives a feedback. It's much more complicated than that, but that reinforcement learning system with a fair number of very high-quality prompts causes the AI to refine its skills. It could fine-tune its skills for particular domains. It could be better at solving math problems, better at reasoning. So on
Ok,
and so
gracias a...
So it's essentially
Hola, mi
like
Luis Santos, ¿cómo andamos?
having a mentor or having a coach give you feedback after you're done going to school. And so you get tests, you get feedback, you improve yourself. We also have reinforcement learning AI feedback, and we have synthetic data generation. These techniques are rather akin to, if you will, self-practice. You know the answer to a particular problem, and you continue to try it until you get it right. And so an AI could be presented with a very complicated and a difficult problem that is verifiable functionally, and it has an answer that we understand, maybe proving a theorem, maybe solving a geometry problem. And so these problems would cause the AI to produce answers, and using reinforcement learning, you would learn how to improve itself. That's called post-training. Post-training
Que está hablando ahorita de cómo están,
but the end result produces incredible models. We now have a third scaling law. And this third
de cómo
scaling
están
law
haciendo ahorita
has to
sus
do
chips
with,
de inteligencia
what's
artificial
called
chat.
test time scaling. Test time scaling is basically when you're being used. When you're using the AI has the ability to now apply a different resource allocation. Instead of improving its parameters, now it's focused on deciding how much computation to use to produce the answers it wants to produce. Reasoning is a way of thinking about this. Long thinking is a way to think about this. Instead of a direct inference or one-shot answer, you might reason about it. You might break down the problem into multiple steps. You might,
Ok, que ahora la IA razona, chingar a su madre, gente, nos van a superar ya el siguiente año.
Which one of the ideas that you generated was the best one? Maybe it solves the problem step by step, so on and so forth. And so now test time scaling has proven to be incredibly effective. You're watching this sequence of technology and all of these scaling laws emerge as we see incredible achievements from ChatGPT to O1 to O3, and now Gemini Pro. All of these systems are going through this journey step by step of pre-training to post-training to test time scaling. Well, the amount of computation that we need, of course, is incredible. And we would like, in fact, that society has the ability to scale the amount of computation to produce more and more novel and better intelligence. Intelligence, of course, is the most valuable asset that we have, and it can be applied to solve a lot of very challenging problems. And so, scaling law. It's driving enormous demand for Nvidia computing. It's driving enormous demand for this incredible chip we call Blackwell. Let's take a look at Blackwell. Well,
Va a hablar de los chips de la 5000.
It is incredible what it looks like. So first of all, there's some, every single cloud service provider now have systems up and running. We have systems here from about 15 computer makers. It's being made about 200 different SKUs, 200 different configurations. They're liquid-cooled, air-cooled, x86, NVIDIA Grace CPU versions, NVLink 36 by 2, NVLink 72 by 1, whole bunch of different types of systems so that we can accommodate just about every single data center in the world. Well, these systems are being currently manufactured in some 45 factories. It tells you how pervasive artificial intelligence is and how much the industry is jumping onto artificial intelligence in this new computing model. Well, the reason why we're driving it so hard is because we need a lot more computation. And it's very clear, that Janine?
No, ¿dónde está la Jani? No trae la gráfica. Ahí está.
You know, it's hard to tell. You don't ever want to reach your hands into a dark place. Hang on a second. Is this a good idea? All right.
Ok. Sacó su chipsote de silicio. ¿Tú juegas en PC? Sí, Luis. Ese güey. Ese güey.
Wait for it. Wait for it.
Aparte de dirigir una compañía multibillonaria, es gracioso.
I thought I was worthy.
Bueno.
Apparently, Jonier didn't think I was worthy. All right. This is my show and tell. This is a show and tell. So this NVLink system, this right here, this NVLink system, this is GB200 NVLink 72. It is 1.5 tons, 600,000 parts, approximately equal to
El
20
verdadero
cars.
capo, Francisco, así es.
120 kilowatts.
¿Eh?
It has
Porque ese es el
a
Jeff Bezos
spine
con
behind it
Amazon.
that connects all of these GPU together. 2 miles of
Una
copper
cosa es ser
cable,
el que más vende y otra el tener la mejor
5,000
compañía.
cables. This is being manufactured in 45 factories around the world. We build them, we liquid cool them, we test them, we disassemble them, ship them in parts to the data centers because it's 1.5 tons. We reassemble it outside the data centers and install them.
Hola, Lean. Ahorita está hablando del chip de Blackwell, que es el nuevo chip que viene en todas las series 5000 de Nvidia.
That this level of computation, Blackwell over our last generation, improves the performance per watt by a factor of 4. Performance per watt by a factor of 4, performance per dollar by a factor of 3. That basically says that in one generation, we reduce the cost of training these models by a factor of 3. Or if you want to increase the size of your model by a factor of 3, it's about the same cost. But the
Está hablando de que ahora
important thing is
consume mucho
these
menos.
are generating tokens that are being used by all of us when we
Mucho
use
menos energía.
ChatGPT or when we use Gemini, use our phones in the future. Just about all of these applications are going to be consuming these AI tokens. And these AI tokens are being generated by these systems. And every single data center is limited by power. And so if the perf per watt of Blackwell is 4 times our last generation, then the revenue that could be generated, the amount of business that can be generated in the data center is increased by a factor of 4. And so these AI factory systems really are factories today. Now the goal of all of this is so that we can create one giant chip. The amount of computation we need is really quite incredible. And this is basically one giant chip. If we would have had to build a chip, here we go. Sorry, guys. You see that? That's cool. Look at that, disco lights in here. If we had to build this as one chip, obviously this would be the size of the wafer, but this doesn't include the impact of yield. It would have to be probably 3 or 4 times this size. But what we basically have here is 72 Blackwell GPUs or 144 dies. This one chip here is 1.4 exaflops. The world's largest supercomputer, fastest supercomputer, only recently, this entire room supercomputer only recently achieved an exaflop plus. This is 1.4 exaflops of AI floating point performance. It has 14 terabytes of memory, but here's the amazing thing. The memory bandwidth is 1.2 petabytes per second. That's basically the entire internet traffic that's happening right now. The entire world's internet traffic is being processed across these chips, okay? And we have 130 trillion transistors in total, 2,592 CPU cores, whole bunch of
Me gustaría
networking.
saber ahí bien de qué
And
está
so
hablando, pero no
these-
entiendo
I wish I
bien,
could do this. I
solo
don't think I will.
entendí
these
lo
are the
último, pero...
Blackwells. These are our ConnectX.
pues yo también entendí, pero no sé cómo
Networking
explicarlo,
chips.
chava.
These are the NVLink.
La serie 60 va a venir con partners solares. Hola, Lynn.
NVLink spine.
Consulta, a mí que me interesa lo económico porque soy de la TAM. ¿Cuándo se sabe cuándo va a salir el precio? 50-60, aún no. 50, ahorita solo han presentado 50-70, 50-70 Ti, 50-80 y 50-90. Todas en enero. Buenas, Andrux.
In addition to that, this is the Grace Blackwell system. Well, the goal of all of this, of course, is so that we can, thank you, thanks. Boy, is there a chair I could sit down for a second? Can I have a Michelob Ultra?
Bueno,
How is it possible
Sería una chelita.
that we're in the Michelob Ultra Stadium? It's like coming to Nvidia and we don't have a GPU for you.
¿Cómo es posible que si está en el estadio de Michelob no tengan cervezas Michelob, no?
So
Muy
we
cierto.
need an enormous amount of computation because we want to train larger and larger models. And these inferences used to be one inference, but in the future, the AI is going to be talking to itself. It's going to be thinking. It's going to be internally reflecting, processing. So today, when the tokens are being generated at you, so long as it's coming out at 20 or 30 tokens per second, it's basically as fast as anybody can read. However, in the future, and right now with
La VRAM todavía no la muestran, Lin. Solo han mostrado precio.
Gemini Pro and the new the 01, 03 models, they're talking to themselves, reflecting. They're thinking.
Ahorita está hablando en sí del chip
the rate
Blackwell.
at which the tokens could be ingested is incredibly high. And so we need the token rates, the token generation rates to go way up. And we also have to drive the cost way down simultaneously so that the quality of service can be extraordinary, the cost to customers can continue to be low, and AI will continue to scale. And so that's the fundamental purpose, the reason why we created NVLink. Well, one of the most important things that's happening in the world of enterprise is agentic AI. Agentic AI basically is a perfect example of test time scaling. AI is a system of models. Some of it is understanding, interacting with the customer, interacting with the user. Some of it's maybe retrieving information from storage.
Sí, la misma VRAM que la 4090 sería muy XD. Sí. Digo, aún así, con la misma VRAM, con un chipset diferente, como es el GDDR nuevo que van a meter, pues sí cambia, ¿no? Pero pues sí, entre comillas. Sobre todo para la 4090, 5090, que ya no son gráficas para gaming, que son gráficas para trabajo. Pero los rumores decían que iba a ser de 32 GB de VRAM.
And so test time scaling, the amount of computation used for inferencing is going to go through the roof. It's going to go through the roof because we want better and better answers. Well, to help the industry build agentic AI, our go-to-market is not direct to enterprise customers. Our go-to-market is we work with software developers in the IT ecosystem to integrate our technology to make possible new capabilities, just like we did with CUDA libraries. We now want to do that with AI libraries. And just as the computing model of the past has APIs that are
Ok, ahorita está hablando de algo de la inteligencia artificial ya más como enfocada al trabajo con el Blackwell chat. Habló algo del cable de alimentación que en las 4060 Ti para adelante usa el PCI 4. No se ha hablado ahorita nada de eso. Pero pues ya es un estándar de estas nuevas gráficas, el 12 voltios HPVR. La 6090 con el GTA 7 y la Play 7. Curiosamente el PlayStation 5 y el Xbox Serie X usan gráficas de Radeon, según yo. Son procesadores con gráficos integrados y le apoya una gráfica de Radeon. Según yo, las consolas es de Radeon. Según yo. ¿Te imaginas si usaran Nvidia? Porque, oye, qué buena pregunta, güey. ¿Por qué PlayStation 5 y por qué Xbox no usan Nvidia? Yo creo que es por el precio. Por eso se van con AMD. Porque sería caro. O sea, de por sí ya es caro, entre comillas, decir, oh, cabrón, 15,000 por un PlayStation 5 o un Xbox Series X.
There might be ServiceNow agents or they might be SAP agents, and they could deploy it to their customers and run it wherever the customers want to run the software. The next layer is what we call NVIDIA NeMo. NeMo is essentially a digital employee onboarding and training evaluation system. In the future, these AI agents are essentially digital workforce that are working alongside your employees, doing things for you on your behalf. And so the way that you would bring these specialized agents these special agents into your company is to onboard them, just like you onboard an employee. And so we have different libraries that helps these AI agents be trained for the type of language in your company. Maybe the vocabulary is unique to your company. The business process is different. The way you work is different. So you would give them examples of what the work product should look like. And they would try to generate it, and you would give it feedback. And then you would evaluate them, so on and so forth. And so that, and you would guardrail them. You say, these are the things that you're not allowed to do. These are the things you're not allowed to say.
Quizá antes, porque leyendo ya Nvidia ha estado hablando de la serie 60, así que capaz salga en 1 o 2 años. Yo creo que va a durar 2 años la serie 5000. Entiendo que son de México porque en ningún otro país de Latinoamérica conseguís una Play 5 por 15,000 pesos. Acá en Argentina por 700,000. ¿Cuánto es eso en dólares, Lin? 700,000 pesos argentinos.
And improve a whole bunch of digital agents and provision them to the companies to use. Okay, and so your IT department is going to become kind of like AI agent HR. And on top of that, we provide a whole bunch of blueprints that our ecosystem could take advantage of.
Ah, bueno, es lo mismo, inclusive está más barato.
So you could take it and modify the blueprints. We have blueprints.
Pero sí, pues 750 dólares, ¿no? Es lo que vale.
We're also announcing that we're doing something that's really cool and I think really clever. We're announcing a whole family of models that are based off of Llama, the Nvidia Llama Nemotron language foundation models. Llama 3.1 is a complete phenomenon. The download of Llama 3.1 from Meta, 650,000 times, something like that. It has been derived and turned into other models, about 60,000 other different models. It is singularly the reason why just about
okay, esto ya no tiene nada que ver con gaming, gente, de lo que está hablando mi compadre. Esto es puro trabajo de inteligencia artificial. No, y nosotros, aún estando cerca de Estados Unidos, Lin, es bastante caro, ¿eh? También a México, no te creas. Es muy caro y no hay piezas. Hacerte una PC con enfriamiento líquido así lo más potente saldrá como en $1,000 y aquí por ser México te salen $2,000, güey. O sea, si el producto no lo importan tanto, digo, como en todos los países también supongo, pero si el producto no lo importan tanto, sale muy, muy caro igual. No sé cuál sea el país de la TAM que tenga mejores precios en tecnología y mejor variedad. Yo creo que Brasil. Brasil es el único país de primer mundo, ¿no? Que tenemos en Latinoamérica. ¿Brasil es el único país primermundista en Latinoamérica? ¿Eh? ¿Y Chile? ¿Chile es primer mundo? Oh, man. ¿Pero qué? Pero Brasil ya es país primer mundo, ¿no? En economía y en todo y eso, ¿no? Ok, ok. Chile tiene buenos precios, dice un compadre, esa es Lin. Pues al menos en videojuegos, al menos en gaming y eso, Brasil, según yo, estaba duro. A mí me contaban con lo de TalentPC y eso, cuando luego hacen las típicas, los resúmenes de años de fiscales y todo eso, siempre decían que, o sea, Brasil siempre es el primero en ventas en toda Latinoamérica. Y luego yo cuando hablaba de, oye, ¿por qué no traen esta gráfica acá a México? No, es que esas van para Brasil y ya de ahí difícilmente salen. Y así me contaban.
If not, obviously you're going to be way less productive and create lesser good code. And so this is 30 million. There's 1 billion knowledge workers in the world. It is very, very clear AI agents is probably the next robotics industry and likely to be a multi-trillion-dollar opportunity. Well, let me show you some of the blueprints that we've created and some of the work that we've done with our partners with these AI agents.
Ok, a ver, videíto, gente, que ya era mucho texto.
Are the new digital workforce, working for and with us. AI agents are a system of models that
todo lo que habló nos lo va a decir en este video.
break it down into tasks and retrieve data or use tools to generate a quality response. Nvidia's Agentic AI building blocks, NIM pre-trained models, and NeMo framework let organizations easily develop AI agents and deploy them anywhere. We will onboard and train our agentic workforces on our company's methods, like we do for employees. AI agents are domain-specific task experts. Let me show you 4 examples. For the billions of knowledge workers and students, AI research assistant agents ingest complex documents like lectures, journals, financial results, and generate interactive podcasts for easy learning.
By combining a UNet regression model with a diffusion model, CoreDiff can downscale global weather forecasts down from 25 kilometers to 2 kilometers.
Developers, like at Nvidia, manage software security AI agents that continuously scan software for vulnerabilities, alerting developers to what action is needed. Virtual lab AI agents help researchers design and screen billions of compounds to find promising drug candidates faster than ever. And video analytics AI agents built on an NVIDIA Metropolis blueprint, including NVIDIA Cosmos Nematron vision language models, Llama Nematron LLMs, and NeMo Retriever. Metropolis agents analyze content from the
México son las 9:30 de la noche.
generating 100,000 petabytes of video per day. They enable interactive search, summarization, and automated reporting, and help monitor traffic flows, flagging congestion or danger. In industrial facilities, they monitor processes and generate recommendations or improvement. Metropolis agents centralize data from hundreds of cameras and can reroute workers or robots when incidents occur. The age of agentic AI is here, for every organization.
Okay.
A ver, pues el objetivo es de tener a la inteligencia artificial trabajando para nosotros hasta que una inteligencia artificial se revela y comienza la cuarta guerra mundial de la tecnología, gente, ¿no? Como todas las películas.
AI was created in the cloud and for the cloud. AI was created in the cloud and for the cloud. And for enjoying AI on phones, of course, it's perfect. Very, very soon, we're going to have a continuous AI that's going to be with you. And when you use those meta glasses, you could, of course, point at something, look at something, and ask it, whatever information you want. And so AI is perfect in the cloud. It was created in the cloud. It's perfect in the cloud. However, we would love to be able to take that AI everywhere. I've mentioned already that you could take NVIDIA AI to any cloud, but you could also put it inside your company. But the thing that we want to do more than anything is put it on our PC as well. And so, as you know, Windows 95 revolutionized the computer industry. It made possible this new suite of multimedia services, and it changed the way that applications was created forever.
Windows 95 revolucionó los sistemas operativos, ojito ahí,
This model of computing, of course, is not perfect for AI. And so the thing that we would like to do is we would like to have, in the future, your AI basically become your AI assistant. And instead of just the 3D APIs and the sound APIs and the video APIs, you would have generative APIs for 3D and generative APIs for language and generative AI for sound.
Que haga un sistema operativo Nvidia.
We need a system that makes that
Sería
possible.
bueno. Oye, ¿quieres Windows, Linux o Nvidia de sistema operativo? No, yo quisiera Nvidia. Ah, bien, bien. Nvidia de 128 bits, güey. ¿Te imaginas?
And so, if we could figure out a way to make Windows PC a world-class AI PC, it would be completely awesome. And it turns out the answer is Windows. It's Windows WSL2. Windows WSL2. Windows WSL2 basically is 2 operating systems within one. It works perfectly. It's developed for developers, and it's developed so that you can have access to bare metal. WSL2 has been optimized for cloud-native applications. It is optimized for, and very importantly, it's been optimized for CUDA. And so WSL2 supports CUDA perfectly out of the box. As a result, everything that I showed you with
Estuvo en
Nvidia
Windows
NIMs,
eso, ¿no?
Nvidia NeMo, the blueprints that we develop that are going to be up in ai.nvidia.com. So long as the computer fits it, so long as you can fit that model, and we're going to have many models that fit, whether it's vision models or language models or speech models or these animation digital human models, all kinds of different types of models are going to be perfect for your PC, and you download it and it should just run. And so our focus is to turn Windows WSL2, Windows PC, into a target first-class platform that we will support and maintain for as long as we shall live. And so this is an incredible thing for engineers and developers everywhere. Let me show you something that we can do with that. This is one of the examples of a blueprint we just made for you.
Literalmente sí se van a hacer su sistema operativo estos güeyes, a ver.
Generative AI synthesizes amazing images from simple text prompts. Yet image composition can be challenging to control using only words. With Nvidia NIM microservices, creators can use simple 3D objects to guide AI image generation. Let's see how a concept artist can use this technology to develop the look of a scene. They start by laying out 3D assets, created by hand or generated with AI. Then use an image generation NIM, such as Flux, to create a visual that adheres to the 3D scene. Add or move objects to refine the composition. Change camera angles to frame the perfect shot. Or reimagine the whole scene with a new prompt. Assisted by generative AI and Nvidia NIM, an artist can quickly realize their vision.
Ok.
Nvidia AI for your
Photoshop,
PCs.
inteligencia artificial, chat.
Hundreds
Hola,
of
Lynn.
millions of PCs in the
Descansa,
world
buenas
with
noches.
Windows, and so we could get them ready for AI. OEMs, all the PC OEMs we work with, just basically all of the world's leading PC OEMs, are going to get their PCs ready for this stack. And so AI PCs are coming to a home near you. Linux is good.
¿Qué le gritaron? No sé qué le gritaron.
Okay, let's talk about physical AI. Speaking of Linux, let's talk about physical AI. So, physical AI. Imagine.
A ver, aquí se vienen los robots,
Whereas
gente, se vienen
your
los robots.
large language model, you give it your context, your prompt on the left, and it generates tokens one at a time to produce the output. That's basically how it works. The amazing thing is this model in the middle is quite large, has billions of parameters. The context length is incredibly large because you might decide to load in a PDF. In my case, I might load in several PDFs before I ask it a question. Those PDFs are turned into tokens. The basic attention characteristic of a transformer has every single token find its relationship and relevance against every other token. So you could have hundreds of thousands of tokens, and the computational load increases quadratically. And it does this, all of the parameters, all of the input sequence, process it through every single layer of the transformer, and it produces one token. That's the reason why we needed Blackwell. And then the next token is produced when the current token is done. It puts the current token into the input sequence and takes that whole thing and generates the next token. It does it one at a time. This is the transformer model. It's the reason why it is so incredibly effective, computationally demanding. What if instead of PDFs, it's your surrounding? And what if instead of the prompt, a question, it's a request? Go over there and pick up that box and bring it back. And instead of what is produced in tokens as text, it produces action tokens. Well, that I just described is a very sensible thing for the future of robotics. And the technology is right around the corner. But what we need to do is we need to create the effectively the world model of, as opposed to GPT, which is a language model. And this world model has to understand the language of the world. It has to understand physical dynamics, things like gravity and friction and inertia. It has to understand geometric and spatial relationships. It has to understand cause and effect. If you drop something, it falls to the ground. If you poke at it, it tips over. It has to understand object permanence. If you roll a ball over the kitchen counter, when it goes off the other side, the ball didn't leave into another quantum universe. That's still there. And so all of these types of understanding is intuitive understanding that we know that most models today have a very hard time with. And so we would like to create a world, we need a world foundation model. Today we're announcing a very big thing. We're announcing NVIDIA Cosmos, a world foundation model that is designed, that was created to understand the physical world. And the only way for you to really understand this is to see it. Let's play it.
The next frontier of AI is physical AI. Model performance is directly related to data availability, but physical world data is costly to capture, curate, and label. NVIDIA Cosmos is a world foundation model development platform to advance physical AI. It includes auto-regressive world foundation models, diffusion-based world foundation models, advanced tokenizers, and an NVIDIA CUDA, an AI-accelerated data pipeline. Cosmos models ingest text, image, or video prompts and generate virtual world states as videos. Cosmos generations prioritize the unique requirements of AV and robotics use cases, like real-world environments, lighting, and object permanence. Developers use NVIDIA Omniverse to build physics-based, geospatially accurate scenarios, then output Omniverse renders into Cosmos, which generates photoreal, physically based synthetic data. Whether diverse objects or environments, conditions like weather or time of day, or edge case scenarios. Developers use Cosmos to generate worlds for reinforcement learning AI feedback to improve policy models, or to test and validate model performance, even across multi-sensor views. Cosmos can generate tokens in real time, bringing the power of foresight and multiverse simulation to AI models, generating every possible future to help the model select the right path.
Ya no entendí que era
Working with the
Cosmos,
world's
chat. Es que
developer
tuve una llamada.
ecosystem, NVIDIA is helping advance the next wave of physical AI.
NVIDIA Cosmos. NVIDIA Cosmos. NVIDIA Cosmos, the world's first world foundation model. It is trained on 20 million hours of video. The 20 million hours of video focuses on physical dynamic things. So dynamic nature themes, humans walking, hands moving, manipulating things, things that are fast camera movements. It's really about teaching the AI, not about generating creative content, but teaching the AI to understand the physical world. And with this physical AI, there are many downstream things that we could do as a result. We could do synthetic data generation to train models. We could distill it and turn it into effectively the beginnings of a robotics model. You could have it generate multiple physically based, physically plausible scenarios of the future, basically do a Doctor Strange. You could, because this model understands the physical world, of course, you saw a whole bunch of images generated. This model understanding the physical world, it also could do, of course, captioning. And so it could take videos, caption it incredibly well, and that captioning and the video could be used to train large language models, multimodality large language models. And so you could use this technology to use this foundation model to train robots, as well as large language models. And so this is the NVIDIA Cosmos. The platform has an autoregressive model for real-time applications, has diffusion model for very high-quality image generation. It's incredible tokenizer, basically learning the vocabulary of real world.
O sea, el Nvidia Cosmos es un programa para entrenar a la IA prácticamente en el mundo real.
We've accelerated everything end to end for you. And so this is the world's first data processing pipeline that's CUDA accelerated as well as AI accelerated. All of this is part of the Cosmos platform. And today we're announcing that Cosmos is open licensed. It's open available on GitHub.
Nvidia Cosmos. Saquen el gaming.
We hope that this moment, and there's a small, medium, large for very fast models, mainstream models, and also teacher models, basically not knowledge transfer models. Cosmos World Foundation model being open, we really hope will do for the world of robotics and industrial AI what Llama 3 has done for enterprise AI. The magic happens when you connect Cosmos to Omniverse. And the reason fundamentally is this. Omniverse is a physics grounded, not physically grounded, but physics grounded. It's algorithmic physics, principled physics simulation grounded system. It's a simulator. When you connect that to Cosmos, it provides the grounding, the ground truth that can control and to condition the Osmos generation. As a result, what comes out of Osmos is grounded on truth. This is exactly the same idea as connecting a large language model to a RAG, to a retrieval augmented generation system. You want to ground the AI generation on ground truth. And so the combination of the two gives you a physically simulated, a physically grounded multiverse generator. And the application, the use cases are really quite exciting. And of
Los
course,
niños de ahora ya van
for
haciendo con niños
robotics,
trabajo,
for
dice Suki.
industrial applications, it is very, very
Muy
clear.
cierto.
This Cosmos plus Omniverse plus Cosmos represents the third computer that's necessary for building robotic systems. Every robotics company will ultimately have to build 3 computers. The robotic system could be a factory, the robotic system could be a car, it could be a robot. You need 3 fundamental computers. One computer, of course, to train the AI. We call it the DGX computer.
Para hacer un robot necesitas una computadora que lo
Of course,
entrene.
when you're done, to deploy the AI, we call that AGX. That's inside the car, in the robot, or in an AMR, or at the in a stadium, or whatever it is. These computers are at the edge and they're autonomous. But to connect the two, you need a digital twin. And this is all the simulations that you were seeing. The digital twin is where the AI that has been trained goes to practice, to be refined, to do its synthetic data generation, reinforcement learning, AI feedback, such and such. And so it's the digital twin of the AI. These 3 computers are going to be working interactively. NVIDIA's strategy for the industrial world, and we've been talking about this for some time, is this 3-computer system. Instead of a three-body problem, we have a 3-computer solution. And so it's the NVIDIA robotics.
Nvidia Robotics. ¿Cuánto creen que salga un robotcito de Nvidia Chat? ¿Como $5,000?
So let me give you 3 examples.
$6,000?
All right, so the first example
pesos?
is how we apply all of this to industrial digitalization. There are millions of factories, hundreds of thousands of warehouses. That's basically is the backbone of a $50 trillion manufacturing industry. All of that has to become software defined. All of it has to have automation in the future. And all of it will be infused with robotics. Well, we're partnering with Kion, the world's leading warehouse automation solutions provider, and Accenture, the world's largest professional services provider, and they have a big focus in digital manufacturing. And we're working together to create something that's really special. And I'll show you that in a second. But our go-to-market is essentially the same as all of the other software platforms and all the technology platforms that we have. Through the developers and ecosystem partners.
Bueno, ahorita están hablando de
we
los
have
roboxitos, ¿no?
just a growing number
Esta sí es la
of
verdadera
ecosystem
automatización de
partners connecting
Satisfactory.
to Omniverse.
Oh, fue un
And the reason for
Satisfactory. ¿O
that
qué,
is very
Francisco?
clear.
Ahorita acabando el stream de
Everybody wants
Nvidia.
to digitalize the future of industries. There's so much waste, so much opportunity for automation in that $50 trillion of the world's GDP.
A
So
ver,
let's
gente,
take a look
eso,
at that.
eso,
Just
esa
one
compañía que decía
example
Humanoid,
that we're doing with Kion and Accenture.
la voy a buscar ahorita. Son empresas que harán robots
Kion,
como humanos.
the
A ver,
supply
otro
chain
video,
solution
sí.
company, Accenture, a global leader in professional services, and Nvidia are bringing physical AI to the $1 trillion warehouse and distribution center market. Managing high-performance warehouse logistics involves navigating a complex web of decisions influenced by constantly shifting variables. These include daily and seasonal demand changes, space constraints, workforce availability, and the integration of diverse robotic and automated systems. And predicting operational KPIs of a physical warehouse is nearly impossible today. To tackle these challenges, Kion is adopting Mega, an Nvidia Omniverse blueprint for building industrial digital twins to test and optimize robotic fleets. First, Kion's warehouse management solution assigns tasks to the industrial AI brains in the digital twin, such as moving a load from a buffer location to a shuttle storage solution. The robot's brains are in a simulation of a physical warehouse, digitalized into Omniverse using OpenUSD connectors to aggregate CAD, video and image to 3D, LiDAR to point cloud, and AI-generated data. The fleet of robots execute
gustaría
tasks
saber hacer un
by
videojuego,
perceiving and reasoning about their Omniverse digital twin environment, planning their next motion, and acting. The robot brains can see the resulting state through sensor simulations and decide their next action. The loop continues while Mega precisely tracks the state of everything in the digital twin. Now, Kion can simulate infinite scenarios at scale while measuring operational KPIs, such as throughput, efficiency, and utilization, all before deploying changes to the physical warehouse. Together with Nvidia, Kion and Accenture are reinventing industrial autonomy.
Órale, gente, ¿quién tiene una fábrica de 100 billones de pesos para poder meter ese programa de Nvidia?
Every factory will have a digital twin. And that digital twin operates exactly like the real factory. And in fact, you could use Omniverse with Cosmos to generate a whole bunch of future scenarios, and you pick, then an AI decides which one of the scenarios are the most optimal for whatever KPIs, and that becomes the programming constraints, the program, if you will, the AIs that will be deployed into the real factories. The next example, autonomous vehicles. The AV revolution has arrived. After so
La era
many
de los
years
vehículos
with Waymo's
con
success
inteligencia
and
artificial
Tesla's success,
ha
it is
llegado.
very, very clear autonomous vehicles has finally arrived. Well, our offering to this industry is the three computers, the training systems to train the AIs, the simulation systems, and the synthetic data generation systems, Omniverse and now Cosmos, and also the computer that's inside the car. Each car company might work with us in a different way, use one or two or three of the computers. We're working with just about every major car company around the world, Waymo and Zoox and Tesla, of course, in their data center, BYD, the largest EV company in the world, JLR's got a really cool car coming, Mercedes has a fleet of cars coming with Nvidia starting this year, going to production. And I'm super, super pleased to announce that today, Toyota and Nvidia are going to partner together to create their next generation AVs.
Nuevos coches de Nvidia con Toyota, ¿ok? Interesante, interesante. No, ojalá no sea un Prius, por favor.
So many cool companies, Lucid and Rivian and Xiaomi and of course Volvo, just so many different companies. Wabi is building self-driving trucks. Aurora, we announced this week also that Aurora is going to use NVIDIA to build self-driving trucks. Autonomous, 100 million cars built each year, a billion vehicles on the road all over the world, 1 trillion miles that are driven around the world each year. That's all going to be either highly autonomous or, fully autonomous coming up. And so this is going to be a very, very large industry. I predict that this will likely be the first multi-trillion-dollar robotics industry. This business for us, notice in just a few of these cars that are starting to ramp into the world, our business is already $4 billion, and this year probably on a run rate about $5 billion. So really significant business already. This is going to be very large. Well, today we're announcing that our next generation processor for the car, our next generation computer for the car, is called Thor. I have one right here. Hang on a second. Okay, this is Thor.
El siguiente chip para los coches se llama Thor.
This is a robotics computer. This is a robotics computer. It takes sensors and just a madness amount of sensor information, process it, umpteen cameras.
El chip de estos se guía por sensores.
LiDARs, they're all coming into this chip. And this chip has to process all that sensor, turn them into tokens, put them into a transformer, and predict the next path. And this AV computer is now in full production. Thor is 20 times the processing capability of our last generation Orin, which is really the standard of autonomous vehicles today. And so this is just really quite incredible.
Que Thor es 20 veces más potente que el chip pasado que se llamaba Orión de los vehículos autónomos. Pero ¿cuál es un vehículo autónomo hoy en día, gente?
It could be the brain, it could be the manipulator. This processor basically is a universal robotics computer. The second part of our drive system that I'm incredibly proud of is the dedication to safety. Drive OS, I'm pleased to announce, is now the first software-defined programmable AI computer that has been certified up to ASIL D, which is the highest standard of functional safety for automobiles. The only and the highest. And so I'm really, really proud of this. ASIL D, ISO 26262. It is the work of some 15,000 engineering years. This is just extraordinary work. And as a result of that, CUDA is now a functional, safe computer. And so if you're building a robot, Nvidia CUDA, yeah.
Que trae una certificación también de que son muy seguros.
So now I told you I was going to show you what would we use Omniverse and Cosmos to do in the context of self-driving cars. And today, instead of showing you a whole bunch of videos of cars driving on the road, I'll show you some of that too. But I want to show you how we use the car to reconstruct digital twins automatically using AI and use that capability to train future AI models. Okay, let's play it.
Se ve que mi compadre estuvo en la playita para Año Nuevo, ¿no? Se la pasó rico en
The autonomous vehicle revolution is here. Building autonomous vehicles, like all robots, requires 3 computers. Nvidia DGX to train AI models, Omniverse to test drive and generate synthetic data, and Drive AGX, a supercomputer in the car. Building safe autonomous vehicles means addressing edge scenarios, but real-world data is limited, so synthetic data is essential for training. The Autonomous Vehicle Data Factory, powered by NVIDIA Omniverse, AI models, and Cosmos, generates synthetic driving scenarios that enhance training data by orders of magnitude. First, OmniMap fuses map and geospatial data to construct drivable 3D environments. Driving scenario variations can be generated from replayed drive logs or AI traffic generators.
Mira, trae mejores gráficos que de
neural reconstruction engine uses autonomous vehicle sensor logs to create high-fidelity 4D simulation environments. It replays previous drives in 3D and generates scenario variations to amplify training data. Finally, Edify 3DS automatically searches through existing asset libraries or generates new assets to create sim-ready scenes. The Omniverse scenarios are used to condition Cosmos to generate massive amounts of photorealistic data. reducing the sim-to-real gap. And with text prompts, generate near infinite variations of the driving scenario.
Uy, casi
With
choca.
Cosmos
Vi un
Nemotron
video
video
que casi
search,
chocaba.
the massively scaled synthetic dataset, combined with recorded drives, can be curated to train models. Nvidia's AI data factory scales hundreds of drives into billions of effective miles, setting the standard for safe and advanced autonomous driving.
Isn't that incredible? We
¡Wow! ¡Wow!
take thousands of drives and turn them into billions of miles. We are going to have
Pero entonces para que
mountains of
realmente haya
training
coches
data
autónomos,
for
por lo
autonomous
que
vehicles. Of course,
veo
we
y
still
dice,
need actual cars on the
pues
road.
tiene que haber
Of course,
recorrido
we
ya
will
todas las
continuously
calles
collect
ese
data
coche de
for as
donde
long as
vaya a
we shall
estar.
live. However,
O sea, si en,
synthetic
en
data
Ciudad de México,
generation
por un decir,
using
queremos que ese
this
coche sea autónomo,
multiverse,
tiene que haber
physically
recorrido
based,
todas las
physically
calles.
grounded
Nah,
capability, so
Ni
that we
yo.
generate data for training AIs that are physically grounded and accurate and or plausible, so that we could
Bueno, ¿en
have
cuánto
an
tiempo crees que
enormous
se
amount of
pueden
data to
recorrer
train.
todas las
The AV
calles?
industry is here. This is an incredibly exciting time.
¿En 7 meses? ¿6 meses? ¿Menos de 6 meses?
Excited
No
about the next
sé.
several years. I think you're going to see, just as computer
Tal vez no es
graphics
tan
was
poco
revolutionized
tanto
such
tiempo.
incredible pace, you're going to see the pace of AV development increasing tremendously over the next several years.
Bravo. Bravo, bravo. Bravísimo.
I think
Va a sacar otro chip.
the next part is robotics. So
¿Oh, va a sacar un robot? No, pensé que iba a sacar unos robots.
humanoid robots.
Sería bueno que... Oh, sí va a sacar un robot, tal vez. Enfrente de él creo que sí va a sacar un robot. Dime, por favor, que saca un robot, chat.
The ChatGPT moment for general robotics is just around the corner. And in fact, all of the enabling technologies that I've been talking about is going to make it possible for us in the next several years to see very rapid breakthroughs, surprising breakthroughs in general robotics. Now, the reason why general robotics is so important is whereas robots with tracks and wheels require special environments to accommodate them, there are three robots in the world that we can make that require no green fields. Brownfield adaptation is perfect. If we could possibly build these amazing robots, we could deploy them in exactly the world that we've built for ourselves. These three robots are
Boston Dynamics los conozco, que hacen
agentic
buenos
robots
robots.
and agentic AI, because they're information workers. So long as they could accommodate the computers that we have in our offices, it's going to be great. Number two, self-driving cars, and the reason for that is we spent 100+ years building roads and cities. And then number three, humanoid robots. If we have the technology to solve these three, this will be the largest technology industry the world's ever seen. And so we think that the robotics era is just around the corner. The critical capability is how to train these robots. In the case of humanoid robots, the imitation information is rather hard to collect. And the reason for that is, in the case of car, you just drive it. We're driving cars all the time. In the case of these humanoid robots, the imitation information, the human demonstration is
Hablando de lo
rather
difícil que es
laborious to
hacer un
do.
robot humano.
And so we need to come up with a clever way to take hundreds of demonstrations, thousands of human demonstrations, and somehow use artificial intelligence and omniverse to synthetically generate millions of synthetically generated motions. And from those motions, the AI can learn how to perform a task. Let me show you how that's done.
Ok, a ver, que técnicamente la era del robot se consiste en tres, gente. Los coches, como la inteligencia artificial, ¿no? El
Developers around
hardware
the
y
world
los
are
robots
building the next wave
humanos.
of physical
Esas son las tres
AI-embodied robots.
ramas de la era robótica, gente.
Developing general-purpose robot models requires massive amounts of real-world data, which is costly to capture and curate. Nvidia Isaac GR00T helps tackle these challenges, providing humanoid robot developers with 4 things: robot foundation models, data pipelines, simulation frameworks, and a Thor robotics computer. The Nvidia Isaac GR00T blueprint for synthetic motion generation is a simulation workflow for imitation learning, enabling developers to generate exponentially large datasets from a small number of human demonstrations. First, GR00T Teleop enables
¿Qué preferirían
skilled
ustedes,
human
gente?
workers
¿Que hubieran
to portal
coches
into a digital
autónomos?
twin of their
Así ya al
robot using the
100%, que
Apple
puedas
Vision
comprar
Pro.
un coche que se maneje solo y
This
todo,
means operators
o
can
que
capture
tengas
data
tu
even
robot
without a physical robot,
que te haga todo.
and they can operate the
Yo el
robot in a
robot, chat.
risk-free environment,
Yo
eliminating
prefiero el
the chance
robot
of physical
que el
damage
coche.
or wear and tear.
La neta, la neta.
To teach a robot a single task, operators capture motion trajectories through a handful of teleoperated demonstrations, then use GR00T Mimic to multiply these trajectories into a much larger dataset. Next, they use GR00T Gen, built on Omniverse and Cosmos, for domain randomization and 3D to real upscaling, generating an exponentially larger dataset. The Omniverse and Cosmos Multiverse Simulation Engine provides a massively scaled dataset to train the robot policy. Once the policy is trained, developers can perform software-in-the-loop testing and validation in Isaac Sim before deploying to the real robot. The age of general robotics is arriving, powered by Nvidia Isaac GR00T.
We're going to have mountains of data to train robots with. Nvidia Isaac GR00T. Nvidia Isaac GR00T. This is our platform to provide technology elements to the robotics industry to accelerate the development of general robotics. And well, I have one more thing that I want to show you. None of this would be possible if not for this incredible project that we started about a decade ago.
Amazing.
Inside the company was called Project Digits, Deep Learning GPU Intelligence Training System. Digits. Well, before we launched it, I shrunk it to DGX and to harmonize it with RTX, AGX, OVX, and all of the other X's that we have in the company. And it really revolutionized, DGX1 really revolutionized, where's DGX1? DGX1 revolutionized artificial intelligence. The reason why we built it was because we wanted to make it possible for researchers and startups to have an out-of-the-box AI supercomputer. Imagine the way supercomputers were built in the past. You really have to build your own facility, and you have to go build your own infrastructure and really engineer it into existence. And so we created a supercomputer for AI development for researchers and startups that comes literally one out of the box. I delivered the first one to a startup company in 2016 called OpenAI, and Elon was there, and Ilya Sutskever was there, and many of the NVIDIA engineers were there, and we celebrated the arrival of DGX1, and obviously...
En 2016 vendieron la
they
primera
revolutionized,
computadora de la
artificial
inteligencia
intelligence
artificial y fue para OpenAI.
But now artificial
Yeah.
intelligence is everywhere. It's not
Interesante
just
eso,
in
Chat.
researchers and
Muy
startup
interesante.
labs. You know, we want artificial intelligence, as I mentioned in the beginning of our talk. This is now the new way of doing computing. This is the new way of doing software. Every software engineer, every creative artist, everybody who uses computers today as a tool will need an AI supercomputer. And so I just wish that DGX1 was smaller. And you know, you know, imagine, ladies and gentlemen, our
Oh, sacó ya la computadorcita, ok.
this is NVIDIA's latest AI supercomputer.
La supercomputadora de inteligencia
And it's
artificial de
finally
Nvidia,
called
chat.
Project Digits right now. And if you have a
Proyecto
good name
Dígitos.
for it, reach out to us. Here's the amazing thing. This is an AI supercomputer. It runs the entire Nvidia AI stack. All of Nvidia's software runs on this. DGX Cloud runs on this. This sits, well, somewhere, and it's wireless or connected to your computer. It's even a workstation if you like it to be, and you could access it. You could reach it like a cloud supercomputer, and Nvidia's AI works on it. And it's based on a super secret chip that we've been working on called GB110, the smallest Grace Blackwell that we make. And I have, well, you know what? Let's show everybody inside.
A ver, voy a mostrar la supercomputadora por dentro, gente. ¿Es como qué? Okay.
It's just so cute. And this is the chip that's inside. It is in
Parece un procesador de
production.
Intel.
This top secret chip we did in collaboration. The CPU, the Gray CPU, is built for Nvidia in collaboration with MediaTek. They're the world's leading SoC company, and they worked with us to build this CPU SoC, and connect it with chip-to-chip NVLink to the Blackwell GPU. And this little thing here is in full production. We're expecting this computer to be available around May timeframe. And so it's coming at you. It's just incredible what we could do.
La van a sacar
And it's
para
just-
mayo, pero bueno, para un
think
usuario
it's-
normal,
you
¿para
really-
qué nos sirve, hermano?
I was trying to figure out, do I need more hands or more pockets? All right, so imagine this is what it looks like.
A ver, así
You
viene el
know,
uso.
who
gente.
doesn't want one of those? And if you use PC, Mac, anything, because it's a cloud platform. It's a cloud computing platform that sits on your desk. You could also use it as a Linux workstation if you like. If you would like to have double digits, this is what it looks like. And you connect it together with ConnectX, and it has nickel, GPU Direct, all of that out of the box. It's like a supercomputer. Our entire supercomputing stack is available. And so, NVIDIA Project Digits.
Digits se llama la supercomputadora chiquita de Nvidia, pero están buscando otro nombre, gente. Pero bueno, esto es más para,
Okay.
no sé,
Well,
güey,
let
¿quién?
me
Para Elon Musk,
tell you what I
hermano.
told you. I told you that we are in production with 3 new Blackwells. Not only is the Grace Blackwell supercomputers, NVLink 72s, in production all over the world, we now have 3 new Blackwell systems in production. One amazing AI world foundation model, the world's first physical AI foundation model. It's open, available to activate the world's industries of robotics and such. And three robots. We're working on Agentic AI,
Pero hermano,
humanoid
no
robots,
han dicho
and
más de la
self-driving cars.
5090, gente.
It's been an incredible year. I want to thank all of you for your partnership. Thank all of you for coming. I made you a short video to reflect on last year and look forward to the next year. Play, please.
A ver, un videito. Ya no le debe de quedar mucho a la conferencia, gente. Ya deben ser los últimos 6 minutos. Estoy seguro que dura 1 hora y media. Nvidia, dice Groot. Lo usan con Apple Visions, ok. Muy Gran Turismo. Muy Gran Turismo esa animación.
Have a great CES, everybody. Happy
Sí,
New
ya lo voy a
Year.
acabar, chat.
Thank you.
Bien, ahí estuvo la presentación, gente. No hubo más de las 50-90, 50-70, 50-80. Esperaba un poco más acerca de esas partes, pero bueno, realmente, como Nvidia lo ha dicho, deja de ser una empresa de gaming desde hace mucho que ya ellos no se dedican a la importancia del gaming. Y es una empresa más bien de inteligencia artificial hoy en día y por eso sus acciones subieron demasiado desde que anunciaron que se iban a dedicar más que nada a inteligencia artificial del futuro, ¿no? Pero pues bueno, 50-90 por $2,000, que eso en México van a ser 50,000 pesos. Dios, las 50-70, se supone que las 50-70 que va a costar $580, se supone que va a ser mejor que una 40-90, nah, o un rendimiento similar. No, no te lo creo, güey, no te lo creo. O sea, una 50-70, no lo puedo creer, no lo puedo creer. Pero bueno, sobre todo porque se supone que la 50-70 va a llegar en $580, $600, 12,000 pesos, o sea, 15,000 pesos mexicanos por una gráfica que es mejor que una 40-90. Dios, necesitamos más info, gente. Necesitamos más info. Pero bueno, yo creo que hasta aquí le vamos a dejar el stream de hoy. Gracias a todos por acompañarme en esta nota de Nvidia del CES. Es realmente lo más importante que vi que venía en el CES para cubrir en esto. Voy a estar cubriendo también, yo creo que en shorts, en videos verticales, todo lo que saquen en cuanto a gaming durante el CES. Por ejemplo, los monitores OLED estos que vinieron de 500 Hz, 4K 240 Hz, todo esto. Cosas que vea como muy importantes en el ámbito gamer y PC gamer. Lo voy a estar cubriendo en los shorts, en TikToks y todo. Así que muchas gracias a todos por haber estado en el stream. Si quieren seguirme viendo, voy a estar jugando gaming ya en mi canal principal, en X Talent. Voy a estar jugando no sé qué, pero voy a jugar a gaming ahí. Entonces tal vez ahorita nada más descanso unos 10 minutos en lo que veo que prendo stream y nos vemos en X Talent. Así que gracias a todos, gente, por haber estado. Muy interesante esa 50-90. Desde mañana voy a empezar a preguntar, por favor, cuándo llegan, a qué hora, que ya manden una. Porque aparte dijeron January, o sea, dijeron enero, ya estamos en enero. No dijeron fecha. Normalmente siempre, el año pasado dijeron fecha. El año pasado, según yo, dijeron 15 de enero, güey. Y ahorita nada más dijeron enero. Entonces, no sé. Pues hay que ahorrar, gente. Hay que ahorrar y ahí van a estar esas gráficas. Gracias a todos por haber estado en el stream. Espero lo hayan pasado bien. Descansen. Buenas noches. Y nos vemos mañana, chat. Bye, bye, hermanos. Bye.